Okay, I think we have some viewers, so let's get started. So what you see is the welcome screen of the Astroberry Server. For those of you that haven't had a chance to came across this system, it's the open source system that is built based on Raspberry Pi, and using that you can actually you can observe and photograph outer space, deep sky objects. So this is the welcome screen that you see in a version 2.0 when you just push start. You can see the main screen of the Astroberry Server. Normally, what I do is to put it on a full screen, so it's easier to navigate. And what I'm showing now is a web-based access, which means that I'm accessing the system from through the web browser. I'm using Firefox on Linux system on Ubuntu 18.04. So that's how it looks like. I mean, there are certain features that I would like to present before we go further. So I mean, I'm using full HD resolution on my screen, but for some of you, it could be the case that you're using some other resolutions lower than that. What is important though is there are features embedded in the system that let you scale the resolution to your screen. Which means if you choose local scaling using the web browser again, I'm not connecting to Raspberry to Astroberry Server using VNC. In the web browser, you have this sliding menu here, and to scale down the resolution, you can just click the local scaling, and if you do, the whole screen will be scaled down to your resolution that you use. So it's a very useful feature. So consider using that if you use lower resolution or smaller screens. All right, but not to stay at this very starting point. In the version 2.01, I introduced some nice features. There is a GPS panel information with a map, the information about satellites that you use and things like that. But also there is an Astro panel which shows you find the Polaris hour angle, but also what's the current status of our satellite, moon, sun, and solar system planets. And again, when using the web-based interface, connecting to Astroberry Server through web browser. Using web browser, I normally start all the drivers from here, not directly from KStars. I already have my profile prepared for my sessions, so what I'm using is Orion CT8 and Attic CCD. I'm also using Attic electronic filter wheel and Astroberry focuser. All right, so if I start these drivers now, they're connected, and I go to the desktop. By the way, the default password is Astroberry, right? So you can see I'm already here where the sliding panel is still on the left hand. I already have the driver started, so I can directly go to KStars, and it's already after sunset, so I will quickly go through making sky flats. And I mean by that the flat frames that I take using clear sky. So starting KStars, then we're starting Ekos. I put it on a separate desktop. It makes things easier. Then I can start Ekos, and as you see, all my drivers are started automatically. There's the Attic driver here, Astroberry Focuser, with some additional features, which includes the temperature compensation and some other things. There's EQ driver for my mount and Attic electronic filter wheel. Anyway, after we start the drivers, we don't need this anymore. So now we can go to our mount, unpark it, and normally I take the sky flats on the east side of the azimuth. So let's move our let's make sure that, oh no, sorry, the azimuth. So that's a Polaris here, so there's North Pole. So azimuth is here. So let's go to the place in the sky where we can take our flats. All right, we are here. So now we can go to Ekos panel, and let's make some flats. Sorry, it's not this one. It should be this one. Let's set the temperature to -10 Celsius degrees, and yeah, we're choosing flats. I use automation when using flats, so I'm setting ADU, which is the one of the parameters of the CCD cameras to average. Let's put it to 25,000 with tolerance 3,000. This means that, and let's just take 20 flats. We don't need these ones. Yeah, 20 flats. So the exposure will be actually automatically set to match the preset ADU. It makes sense. So first, as you see, the temperature is set. It takes a while to get to -10, but we'll be there in a minute. Yeah, it's getting lower. We'll yeah, I hope it's not getting too dark for doing that, but yeah, we're almost there. Yeah, I should have done that before actually, so you know, it's not taking so much time, but it's fine. And as soon as the temperature gets to -10, the session will start, and as you will see, the first frame will be taken with a 1 second exposure, as we set in our panel. Oh, here we go. So we can say now it's evenly illuminated, of course, because we're just looking at the sky. So the first picture is taken, and the exposure of 1 second. Here we go. Yeah. All right. So it's yeah, it looks like it's too dark, right? And what we can tell where we are based on the informations here. We're at the 22,000 ADU, which is below our threshold. We set the threshold at 25,000. Sorry. Oh, it was just a joke. So now the current ADU should be increased by increasing the exposure time. Here we are, and now you can see there is a 25,000 ADU automatically selected by Ekos, and actually, what you can do also, what I'm doing normally in this type of situation, to make it easier to remove the stars that I can pick during making flats, I'm switching off tracking. So the stars will be removed at when we do the flat. I mean the stacking of the flat. All right. So here we go. We come back. As you see, the stars are moved now because we switched off the stacking, so the tracking, I should say. So they will be easily removed when stacking the flat frame. Well, it's a live session, so it could be a bit boring for you because everything takes time. Actually, when observing the sky, the night sky, you have to be very patient. Oh yeah, but anyway, 10 frames already there. You can actually very easily access them on the Raspberry Pi, because just using the file manager, you over the network, you can just easily make sure that they are there. Luminance flats, as you see. Moreover, we can actually open them. So let's switch to pics inside. Bam. And here is the first flat that we took. We can actually let's see. So there's our flat. Well, it's probably not perfect, but let's check it out. Well, it's not that bad. Pretty much what you would expect. All right, let's close this one and let's come back to our Astroberry. So 12 floods after us. Actually, the exposure needs to be changed again because of the fact that we're taking the sky flood, which means that it's getting darker, right? So the light situation changes, and Ekos needs to adjust the exposure time. So the floods are made according to your specification, which was 25,000 ADO plus minus 3,000. So yeah, we started a bit too late. So I don't think we can. We'll see, but I don't think we can take all of them as we wanted. But we'll see, maybe. We'll see. No, there's a question whether I'm stacking floods on the fly. Not really. I'm taking separate frames and I'm stacking them afterwards. I mean, you can do the auto stacking, indeed, but normally, I mean, it's not very useful because still you're using floods to calibrate your light frames. So I'm doing it afterwards, which means that I'm just taking. Normally, I'm taking 20 to 40 flats. 40 flat frames, and then I'm I'm going directly to light frames. I mean, we'll probably wait a bit to make sure that the sky is dark, but so I keep my flat frames and I'm stacking that afterwards and coming back to them when stacking the light frames. And of course, I mean, by the way, the comment from Darek is very valid. I mean, you don't need to take flats every single session. Actually, if you don't change your optical train, and I mean by that, you don't change focus, you don't, you're not rotating your frame, you just leave it as it is. So you can actually use flats from a single session. You can reuse them. Yeah, and for what I'm using for stacking, yeah, I'm keen on peaks inside, so I'm using peaks inside for that. I just love this software. I mean, and I fully recommend it to anybody that. I mean, you can have full control over the process in peaks inside, and that's really cool. All right, so yeah, we're done. It looks like, as you see, it's complete. So yeah, so we can leave it as it is. Let's take a look at our file manager flats again. Yeah, so we have even 21 flats, and normally I can move them to my PC over the network. Again, we can open one of them in Pigs Inside. Yeah. So here's another one. So you see. Yeah, actually, what we can do is we can we can make a quick stacking, right? I will move the files. I will move these flats to my PC and I will stack them. Yeah, let's do that. So because we'll have to wait for dark sky anyway. So actually, I was not prepared to do this, but I can easily change that. So there is a let me go to calibration frames. Yeah, what I do, let me do this. All right, so so here are our flats. It's 27th of March. So what I do, I tend to keep my flats. So we'll do the same this time, and of course what you're using as your equipment for making flats makes difference. So I keep them this way. So we have 27th of March 2020. Here we go, and this is the luminance flats. So let's move them to our PC. All right, and as soon as we do that, we can actually go directly to the ping to our peaks inside, right? All right, let's get there. And the way you should stack the, I mean, there are certain things that you can skip when stacking the flats, but normally the process should include, I mean, you should actually calibrate your flats first, right? So you should calibrate your flats using bias frame and dark frames. And let me do that for you. Actually, let's do that. I mean, yeah. So we have our flat frames that we have just taken. All right. Then we select the director where we're gonna put the calibrated flat frames. Then we select bias frame, and I already have it. It's already stacked and ready to use. And as you see, I have taken it in February. I took it in February, right? So it's these are not taken today. Then I use master dark, and I mean, it doesn't matter really what dark frame you're using, because Pix Insight will optimize. So what I mean by that is you don't have to use the time, the exposure time of your master dark frames the same as flat frames, right? There's no need for that. I mean, if you're using the same time of your dark frames as flat frames, you're actually these are not dark frames anymore, because this means that you're using dark flats, right? Dark flats. Okay. Anyway, so I will choose master dark taken with the exposure time 120 seconds with a temperature at the temperature minus 10 Celsius degrees. Yeah, I'm calibrating flats, so I don't need this. All right, and so we start calibration. All right, it's done. Now we go to image integration, right? So we have our flats, because the remark that I made at the very beginning was that you can do various ways. I mean, there are people that don't calibrate flat frames, but that means that you don't remove dark noise from your flats, right? In certain cases, for certain CCD cameras, that's okay, and you will be really fine. But normally, to make sure that the process is complete and the flats are really noise-free, you should calibrate your flat frames first. All right, so we have them calibrated. Here you go. So we have it's too few actually. 20 flat frames. It's not enough normally. I mean, normally I would take 40, but let's play with this one. So we have 21 flat frames, and yeah, we load them here. The combination method we should use is average, but we normally the light frames are stacked with additive width scaling algorithm normalization, but we're using multiplicative because we'll be using them to calibrate the light frames, and we don't care about the noise. All right, then we of course want to reject some outliers. So depending on the number of frames, you can use various algorithms, as you see. When using 20 or more frames, Winsorized sigma clipping is the way to go. And again, for the normalization, for the flat frames, we're using equalized fluxes. All right? So as soon as we do that, we can start integration. And so the Pix is doing his job. Yeah. All right. So we have a rejection high map. As you see, all the stars that they were moving because we switched off tracking. They are rejected, which is good for us because they will not be visible on the flat frame. Rejection low. There are some pixels rejected, and there is our flat. Here we go. So let's see how it looks like. Here we go. It's your perfect flat. As you see, there are some donuts here. I mean, yeah, that's exactly the reason, one of two reasons to make flats. First of them is the field of view. As you see, and this is inherent part of the optics. I mean, you never, never maybe is a too strong word, but I mean, it is very rare that you have a flat frame. If you have a flat frame directly from your camera, you don't need flat frames. So first of all, there is some inconsistent light on your frame. The center is lighter, the corners are darker. So the reason to use flat frames is to make your light frames flat, which means they will be evenly illuminated. The second reason to use flats is to remove all these donuts from your pictures, because otherwise every single light frame will have them registered. Even if you don't see them, they are there, and the flat frame will make them disappear. All right, so that's how the flat field looks like. We can then save our flat frame. All right, there are some objects here, flats. Yeah, just to make things easier, the naming I'm using, as you see, master flat, scope, camera, filter, and date. This way you can come back to the flats that you, oh, no, that's not the thing that we're gonna do. You wanna use the name convention, so it's here, but we're gonna save it under new date, so it's March 27th. Here you go. So here's our flat. All right, you don't stretch it, you don't change it, you keep it as it is. All right, so let's come back to Astroberry now. I'm still learning how to operate all around this streaming software, so I'm a bit lost, but I hope you're not. All right. There are some comments, so let me take a look at the comment. I'm back to Astroberry, but so let's switch to map. Oh no, let's do this. I mean, first of all, let's start tracking again, right? Because we stopped tracking. So yeah, so let's move somewhere. So the telescope is slowing. All right. And again, everything that we see, I mean now, because the Pix Insight is running on my PC, but everything that we're seeing now is running directly from Raspberry Pi that is connected to my telescope. All right, so here we go. Let me take a look at the comments, because I was busy with the flats for a while. Hot pixels? No, I don't think so. I mean, actually, I do have hot pixels on my camera. That's typical, but I don't think that we have some hot pixels on the flat. All right. All right. How did I move the icons to the left side from the top? What do you mean, Astromelly? Yeah. You can answer in a comment in a minute. All right, so we moved our telescope to Megrez, as you see. That is my target, right? But for various reasons, the telescope could be pointing in some maybe not other direction, but in the direction that is not precisely Megrez. All right. So how to address that? That's the things that I'm gonna do now are really exactly how I work with our sessions, with my sessions, Astro sessions. So after pointing my telescope at the very beginning of a session, after pointing my scope to any object, what I do first is to check focus. Oh, you mean the icons? Yeah. Coming back to question from Astromelly, you can move your icons to left hand side using KStars settings. Configure KStars, Ekos. No, or actually it is probably in advanced, yeah, advanced settings, look and feel, and then you, well, where was it? Yeah, somewhere here. Let me check. Maybe that's not the way to go. Let's come back to Ekos, and if I click, yeah, that's somewhere in options. I don't remember that now, saying truth, but it should be somewhere here. If I click options, oh yeah. So if you go to Ekos, general settings for Ekos, so you can see icons orientation, right? And I have chosen left, and that's it. All right. Okay, so let's come back to what I started to explain. So after pointing to a specific place, to the first place I actually point my telescope to. The first of all, first thing you have to do is to check your focus, obviously, and Ekos helps you out with that. So let's take a frame. Actually, my focus should be fine because I'm keeping that consistent between the sessions. So some adjustments still will be needed probably. All right, here you go. Oh, and pointing is not that bad probably. So there is some stars in our frame. So let's choose a star. Yeah, and there are certain things that I already have configured. So what you see here is probably not default way that Ekos would behave, right? So first of all, I don't use auto select star. I don't use it. I prefer to use manual selection. Second, I use subframe. So after clicking a star, you see just the subframe. I don't focus on a full frame. All right. Second. Oh, there are some Polish questions from Darek. Yes, these were stars, not hot pixels. Second, and it could be the case that we're talking about, some problems with resolutions on YouTube. I'm not sure of that, but as you know, that making the live sessions, Astro sessions, it's a challenge because every pixel matters, and maybe you weren't able to see that, but yeah, these were stars. And the second question is if I have my t-shirt on my scope. No, when doing sky flats, I don't use t-shirt. I just do direct images of the sky. All right, let's come back to the session. So we have a star. It's not perfectly focused. So we can focus manually, right? So we can focus in, check. Right? Oh, it's better, right? We can also use start framing. The start framing button works the way that it just it takes pictures in a loop. This way you can see what is the half flux radius, HFR, on a screen, between the captures, and you can focus manually, observing the HFR in the real time, right? Normally I don't do that. I use autofocus, and I only correct focus when really needed. So let's try autofocus then. There are various algorithms to autofocus in Ekos. So first of all, when using autofocus, you should preset certain parameters for mechanics of your focuser. What is the initial step size? I mean, what is the step between autofocus tries to optimize the focus? What is the maximum step size? And this matters only for linear focusing, and I'm gonna show you this one specifically. It's a new algorithm that was added to Ekos, I don't know, probably a month or 2 months ago or so, as far as I remember. And when using this linear focusing algorithm, you should set maximum step size, and I'm gonna explain it in a minute. There's a settings, which means that a focuser will take a rest of for a while before doing another step and things like that. Anyway, so let's try this linear algorithm, and with the SEP star selection detection, I should say. All right. This way, we can build the actual V curve when autofocusing. So let's start at. We're pretty on a spot, but it's 1.88 HFR with 1 times 1 binning, which means that we're not binning. We're not binning down. Anyway, I'm just checking the transmission because there's some. I'm not sure if. Oh yeah, that's okay. All right. So let's autofocus. Yeah. So first, the focuser will go outwards by maximum step size, 80 steps. It makes the star out of focus. All right. All right. Then it starts to move inward by 20 steps. Right? That's what we said. And you see it's building the right hand of the V curve. That's very interesting algorithm. I'm using it. I was using that for last couple of sessions, and it works really, really, really well. And you see, it crossed the focus point, so the star is getting worse. But this way, you can actually calculate the best focus point. And after that, it comes back again on the right side and moves down to the perfect focus. Why is that so? I mean, the reason is that it's not coming back to the best focus on the left side, because this way it actually addresses backlash. So it's coming to focus from the same side So there's no, so if you have any backlash in your focuser, it doesn't matter. And as you see, the setting is complete, and autofocus complete after 14 iterations. So we started with the manual focus being at 1.88. Now we achieved HFR at 1.72. All right, we're in focus. I would say there's no need for further adjustments. If we want to check how it looks like on a full frame, we can always click reset button and then capture a picture. After a while, and I'm taking 3 seconds per frame. It's 3 seconds, right? So yeah, here we go. And that's our frame, how it looks like after this focusing algorithm. If I click the big star, so it retakes a frame, and as you see on the spikes that we really spot on. All right, so let's come back to our sky map. And well, as you see, I was pointing at Megrez, and again, even on the focus frame, we can see that we're not really, the star is not in the center. It's not really in the center, right? So let's check it out again. All right. We see that it's not perfectly in the center. How to make it better? All right. Remember that that's it's really first object that I'm pointing at right now. So so the thing is that you have to make sure that that your telescope is synced with your sky map. How to achieve this? And that's I found it one of the best parts of Ekos, because it makes it very, very easy to make go-to work just perfectly. We're going to a line tab, right? So our scope is already focused. It's pointing on a certain point on the sky, and now we want to make it better. To point to any certain point on the sky. In the meantime, there's a question from Astroberry, which focuser I use. Actually, I use RoboFocus Moto, but I don't use it with the original controller. I'm using Astroberry Focuser. It's open source focuser that I built some time ago for any single stepper motor that you can find on the market. I mean, you can use any stepper motor as a focuser. I will show it in a minute. All right, so let's come back to aligning tab. As we pointing at a certain point on the sky, we can use two. As for now, Ekos is supporting two plate solving softwares. It's ASTAP or astrometry.net. All right. I'm very keen on astrometry, and that's what I'm using. You can use online version, which means that an image that you take, a picture that you take, will be uploaded to astrometry.net website. It will be resolved there, and the results will be sent back to your session. But this assumes that you have your internet connection, right? I mean, you cannot use it when doing the session in the field with no internet connection. So it's not that easy. What I'm using, I use offline mode, which means that you have to have your index files on your Raspberry, on your system, so you can resolve the image, every image, locally. Okay, so there are index files. They are marked with these icons: required, recommended, and optional. Where do they come from? I mean, as soon as you configure your telescope, setting your focal length and aperture, the index files will be selected for you. I mean, which you really need for your field of view. So for the current field of view that I use, which is 47 by 38 minutes, arc minutes, I need number of index files, and just clicking on the ones that that are not selected will download index file for you and install it directly to your Raspberry. But just remember to choose the location, because if you choose user share astrometry, it will not work, because KStars does not have right access to this directory. What you can do, you can choose your astrometry local share KStars astrometry directory, which is your local user directory, and the index files will be downloaded for you. Let me show you that. I mean, I have my index files already downloaded, but why don't we try? If I click local here, as I said, and I choose, let me choose something really small, because there's no time for downloading too many index files. Let me choose this one. It's optional, right? And as you see, it's downloaded and already installed on your system. You can easily remove it by just unclicking that. And that's it. All right, so let's come back to that. So again, we are pointing at a certain point in the sky. We want to make sure that the telescope is synced with your sky map. You're clicking sync option here, which is synchronize the telescope to the solution coordinates. I choose astrometry.net offline mode, and I do just one single thing, which is clicking capture and solve. So the picture takes 10 seconds to capture, and it just takes, it's already solved and synced. It just took a few seconds, to be specific 5 seconds, to solve the image. Solver completed in 5 seconds, as you see. That's how it works. What does it mean? Let's come back to our map. Let's zoom in to our star. And as you see, the yellow frame is the actual field of view after solving the picture. But this means that after syncing, when I go to this star again, the telescope is moving to this star, and let's check how it looks like now. I'm using Focus tab as a preview very often, so let's do this way. Let's click Capture. And here you go. It's spot on. How does it help you? Actually, it's well, it helps you a lot. Let me show you that. After just one single sync, which means syncing your telescope to a single point. Let's point to south again. Syncing to a single point lets you. Oh, where's our telescope mark? Actually, oh yeah, it's above. Let's check M44. Shall we? Beehive cluster. Let's go to this object. All right. Let me see that. Let's go to, yeah, let's check on the focus again. All right. Oh, so we're a bit off, but I can tell you one thing. After the first sync, what I do, I select slew to target. So all the subsequent streams, all the subsequent slews are really spot on. Which this procedure actually makes Ekos to recapture the image a few times and play solving that a few times as much as possible, or I should say the other way around, until you get the object within 30 seconds arc seconds accuracy. So let's do that. As you see, that's the first picture taken. Its accuracy is not met, as you see. So it's retaking a picture. I mean, it's moving the scope and then retaking a picture. Here we go. And you see, within just 2 steps, target is within acceptable range. And acceptable range means the center of the object is within 30 arc seconds precision. So it's not that bad, right? All right. We can of course check the focus and all the other things, but let's move to the actual session. Before we do that, let's start our PhD. It's always a challenge. I'm using 900 millimeter scope, so it's always a challenge to to guide this type of telescope, but that's fine. Yeah, we have a star. We can start guiding. And the settings of the PhD tool, which you find here down on the bar or in the advanced tab, I mean they really need some time to to optimize. It really depends on the hardware, and there's even some magic behind it. All right, so we're guiding on a star within the M44 object, and as you see, the name is already preset after plate solving. And let's make some images here. So I don't know. Let's do something like 3 minutes, and some, I don't know. Let's start with just one picture. Yeah, so we don't lose time. Luminance, exposure time 180 seconds. One image, binning set at 1, and what I tend to use recently is to use local mode, so we're not transferring the images of a network to our PC, or we're just writing the images directly to where Ekos and KStars are sitting. Bang. Here we go. Oh, and by the way, the -10 is already set, so I didn't need to change it. But in case you wanna set your temperature, remember that that setting to be configured before you start your session. All right, let's check the guiding again. Yeah, it's not that bad. Actually, it is quite bad. Yeah, but anyway, it's just a demo. And let's start. So it's gonna take a few minutes, and being precise, it's gonna take 3 minutes. So in the meantime, let me see your questions if there are. Astap. Astroberry uses Astap. Well, I have tested it. It's fine and fast, but I'm too traditional probably. It works really well and doesn't require a lot of these index files, but I'm quite used to Astrometry.net and that's why I was showing this one. All right. So we're waiting here. Any questions from your side? We would be more than happy to answer them. We're it's almost it's over an hour that we're doing this, so I don't think that that anybody can stand longer than that, but unless you want me to point to a specific object and take a picture. So why don't we do that? Voting. And oh, by the way, actually, I'm recording this session, so after we finish the live stream, I will upload this to YouTube channel, so you can watch that again and make sure that everything is clear and fine. Oh, that's fine. Thank you, Astroberry. I'm very glad that people use this. I'm really. I primarily a few years ago, it was like 6 years ago, I primarily made it for myself. But after I realized that there are some people that would appreciate using some smart device like Astroberry, and that's really cool that you like it. It's not my full-time job. Actually, it's I'm I'm for living I'm doing something else. I do something else. So really it's after hours exercise. So really I do appreciate that you find it useful. Alright, we have some low bandwidth problem for a while, but yeah, there is some problem with capture. Why the hell is doing this? I don't like it. Yeah, it's because of the declination axis that's getting crazy. Anyway, let me do this. I will restart that and we'll see a picture, at least one today, and we'll be finishing. Okay, is the Nikon D5000 with key and turning relay board shutter release supported yet? Well, I don't know. It's a very specific question, but yeah, we can leave a leave a comment. Or actually, the chat will be saved. So let me come back to you with the answer to this question. I don't know if this device is supported. All right, so the guiding is really crazy. It's not gonna make us good picture whatsoever. But I'm not gonna spend time on that now. It's not. I will probably have to recalibrate it later on, but I don't wanna spend time on that. So I hope that at least we'll get a single image. Let's switch off the guiding guard, right? Because it's going beyond 2.5 arc seconds, it will abort again. So let's just test how it looks like, and and we'll see. And when using local mode, you will not see a preview of your picture. You will have to check the file that's written on the Raspberry Pi. All right. So there's like 30 seconds to go, and we'll be closing this live session. It's the first one for Astroberry, but if you like it, just leave some comments and and recommend that and share among your friends. If you think that's useful, I mean, we can I can do some other sessions in the future. I have never done that before. It's so believe me or not, but it's the very first live session for me. All right, so the image is almost done. It should be written. Yeah, it's finished, right? It's already finished, and the image is. Oh, I made a mistake. You see, I didn't change that to light frame. Anyway, doesn't matter. It doesn't matter really. Let's check the picture. It's not gonna be useful, but yeah, file manager, and we're going to no, it's not this one, right? So we have it here really. Instead of finding that in lights, we'll find it in flats, which is not what we wanted. Let's open it in PixInsight, and here we go in PixInsight. Yeah. As you see, I'm on a really bad sky, but don't worry, you can easily find the way to correct it. The easiest way to correct it, and that's gonna be the last thing that I'm gonna show you. In PixInsight, you can do the automatic background extractor, and it's not calibrated, right? I mean, we took some flats to do that, but I'm not gonna do that this time. I'm gonna use some automation here. So I'm gonna use a automatic background extractor, correcting the image as it would be calibrated with a flat. That's why I'm using division, and you use it for flats only. All right, bang. Here you go. So this way, that's pretty much how our flat looked like, right? I hope you're gonna see. I mean, you see it, right? Yeah. So it was the light frame was divided by this artificial flat, and that's the result. That's the result. Of course, it's not stretched. So normally you can, as for preview, you can do this. But as you see, not using the real flats will leave you with donuts, right? But you can correct every single aspect of this picture in the PixInsight. Yeah, that's how it looks like. All right, that's the first image that we took in our session, the first Astroberry Server live session, and let's make it happen again then. All right, thank you very much, guys. I do appreciate that you found some time on spending on this session with me. I will be more than happy to organize that for you again and again. If only time allows for that, I would be happy to present some features. That would be very useful if you actually help me out with that using Astroberry Server profile on Facebook, and if you put some request for presentation in comments under this live session post, I will organize the next sessions for you that would include this information that you want to see. All right. Thanks a lot. Thank you very much for joining, and see you soon.